Oh, sorry. Let's just get here. Yeah, I provided some links that I think will be useful. This is, of course, the Python API for TensorFlow. This is TF.js. I've added some links on how to access Drive, Google Docs, Google Cloud Storage from Colab, but you'll realize that it's actually easier than you see because they have an option to mount a drive, which is what I'll use, the simplest way to do it. You can access BigQuery, AutoML, anything. Here's a link to understand how to convert a Python's saved model. Saved model is language agnostic. It is originally written in C++, and that can be translated into anything. And I'll try to do that to JSON, which Praful should be able to consume. I will also try to translate it into Onyx. Saved model is something that R should be able to consume, but there is very little documentation on that. So I'm still in the dark about this. So this is what I'll try to do. You could also use Colab as a server, which makes very little sense. So I've added some links just so if you want to do that, you can create an API. This is similar to Flask, and you can set up an asynchronous server, and then you can create a tunnel from Colab to some public URL where a person can interact with your APIs. So I'm just giving you this option, but I'm not planning to do that today. So let's try to build a model. So I go to my Colab account. So I create a new notebook. So yeah, let's call this from, let's say, Python to TF.js. Yeah, so what I need for this is first, I will need something called TensorFlow converter. So I'm going to install this, and where is it? Actually, this link is the most useful one. It's right here. If you click on this one. So this will go step by step exactly how you should move from Python saved model to TensorFlow.js all the way till deployment. They tell you every single step. So what I'm going to do first is I'm going to install this TensorFlow.js. And another thing that I'll need is Onyx. So for Onyx, I need to Onyx. So this will move me from TensorFlow to Onyx. And the package that I need for that is this one, TF to Onyx. So I'm going to install that now. You could call the terminal by this link, but you can also call terminal from here. So by just using exclamation mark, when you use exclamation mark, this triggers the terminal. So I'm going to do pip install. I needed TensorFlow.js and TensorFlow.js, and I needed TF to Onyx. And quiet just tells me that I don't want to print out every single step of this installation. So it just quickly tells me that it's done. So as it's installing, I'm going to import OS. OS is going to help me communicate with the file system within the notebook. And so this is me importing the TensorFlow library for Python. I'm going to use the MNIST library, so I'll try to plot it. So I'm going to do import matplotlib.py plot as plt. So this is helping me with the graphing. What else do I need? I'm going to show you a trick by which you can, without using TensorBoard, you can monitor the convergence. So I'm going to need Pandas for that. And also, I'm also going to import NumPy. All of this is pre-installed into Colab, so I'm not installing it this way anymore. I don't have to set up the entire virtual environment. These are regular libraries that I use for machine learning, and these are pre-installed. I think this should be sufficient. I'm going to call these two from the command line, so I'm not going to import anything
AJ,
here.
just to be completely sure, TensorFlow does not, the TensorFlow in Python does not depend in any of those other libraries, correct?
What do you mean other libraries?
The Pandas, NumPy, Matplotlib, and so on. So just to make sure, so the TensorFlow library is this,
yeah. I can do the whole thing without any of this. I can do the whole thing here. Okay. I'm just, these are just embellishments, as you'll see. I'll tell you exactly when I'm using.
The reason I'm asking, Jay, is that later on, for instance, I'll be tempted to repeat every command you write from now on, entirely inobservable. So my only dependence would be TF. I wouldn't have any.
This is completely remote, because if you have TensorFlow, you have a variant of NumPy, and it's pretty good. So yes. it makes no sense to. And again, Pandas is not necessary because TF has something called data, and TF.js also has data. So I have a link here. So if you go into the APIs, you'll realize that they have their data libraries as well. So you wouldn't need something like Pandas. Where is it? Training, performance. Yeah, this one. So this will help you do any kind of pre-processing that you need. So it makes no sense for me to import any of these things. I don't need a graphing library unless you can use TensorBoard, but I'm going to just show you another trick. So I think this is all I need. Yeah. What I'm going to do is I'm going to demo this with MNest. So let's just take a quick look at the Python library. In Python, where is API? I'll go to the latest one. And I'm going to, within Keras, you have some data sets, public data sets. These are pretty standard ones. If you want more options, then I recommend TF.js. Yeah, so TensorFlow datasets has a lot more options. So if you want more options, you can go here. So this is good for federated learning as well. But I'm going to use something simple. I'm just going to use the standard MNest one. So this is how you load data there, this way. So I'm going to do that first. Train, y train, and it comes as a tuple. In a real world scenario, you'd probably also split train into validation, but I'm not going to do that today because MNest never overfits. Keras.datasets.mnest. So it gives you all this command completion, the auto completion as well. This should be sufficient. Now you'll see how it's downloading. It's actually downloading from a GCS. Location, and this is a NumPy format, and that gets translated into, this is actually NumPy also. I'll show you that. So if you look at, type. So here you can see that it's a NumPy n-dimensional array. There are a few things that you need to make sure. The problem with MNest dataset is that a lot of public dataset tends to be rotated because the original MNest dataset was rotated 90 degrees. So for that reason, I imported a visualization library. You can use Plotly, of course. So I'm going to just try to visualize the first 5 examples in the training set. So for that, I need spec access DLT. This is matplotlib. This is pyplot. That's this library. I'm going to import subplots. And the number of rows that I need in this visualization is 1. The number of columns I need is n calls. That's 5 examples. And then for each axis I in range of n calls, I want to visualize, that's in the ith axis, I want to visualize, this is image show. Yeah, I want to visualize the ith example. So this makes me visual. And CMap is color map. I want to make it grayscale. That's it. I'm also going to label it from, so if I set title, the title of the image will contain the class value. And I get the class value from ytrain. So I'm visualizing the ith example from train, and I'm printing out as the title of the image the class of that image. Okay, I think this should be enough. Yeah. So you can see that the first 5 images in the training data set is this 5, 0, 4, 1, 9, and you can see that the class matches 5, 0, 4, 1, 9. The good news for me is that this is not rotated. So if you guys are using different ways of importing the MNIST data set, try to visualize and make sure it's not 90-degree rotated. If it is, you need to add an additional pre-processing step that rotates it back to this way. Okay, so I think we can start modeling. I just wanted to show you one more thing. Another pre-processing step is that you need to make sure that all of your values are either ranging from -1 to 1 or 0 to 1. So I need to know the range. Let me do the minimum value of xtrain in the ith example, the 0th example. And I also want to know the max value. So this will give me the range of values it takes. So it goes from 0 to 255, which is not surprising because this is the data type of this is an integer with 8 bits, and it ranges from 0 to 255. This means that if I divide this entire image by 255, I can normalize it from 0 to 1. But this is something that I've been trying to do lately. I'm trying to not pre-process before the model. I'm trying to make sure that all the pre-processing is done at the model stage. This can be a little tricky, and this might break at the JavaScript level. So if it breaks at the JavaScript level, I would know. Even before Praful knows, I would know that something is going to happen. And I'll explain to you how that happens. But for now, all pre-processing I'm going to do at the model level. So let's start building a model.
Jeya?
Yeah.
Are the images themselves, are they tensors or are they just an array?
It's an array. It's an array, but so in Python, a NumPy array and a TF tensor are not that different. You can pretty much exchange it even in the middle of the training.
I see. Okay.
Yeah. So you'll realize that even if I feed it in a NumPy array, it's actually going to get converted into tensors.
Got it. Thanks.
AJ, since we are breaking your flow, do you mind commenting on your preference for model level pre-processing? I know there is a lot of thought going into that.
It's clear. So you guys will see it right now. So if I had done any pre-processing, if I had done any kind of rotation to the image, and I had done scaling, and then I passed it to Praful and I asked him to rerun the model, he would have to redo all of these steps. I would have to communicate in some way to him that I had rotated it by 90 degrees. I had scaled it from 0 to 1. Now he would have to do that in JavaScript. This is not a good idea. If I send this to Daniel and I asked him to run this in R, he would have to repeat the same thing in R. I don't think that these are portable ideas. And these days, what's happening is you'll notice that in Keras, within layers, they're starting to give you pre-processing steps. So if you wanted to rotate that image, if it was indeed 90-degree rotated, you can do that here, right? Random rotation. Oh, this is randomly rotating, but there is a way to rotate it specifically. I forgot where it was. But you see these kind of layers, and now I'm going to use rescaling. Rescaling is going to scale my value from 0 to 1. All I have to do is specify a scale value. I can resize it. If the images come in any format, any number of pixels, length and height, I want to resize it to some fixed size. I can do that at the model level now. Do I want to reshape the array? Do it at the model level. Don't do it at the code level.
Yeah. Jay, out of curiosity, when you print the model, would this be there? Will there be a little box explaining exactly how the pre-processing was done?
Yeah, it'll be there. I'll show you a slightly different visualization than the one I showed you that day, because here you'll have to also set up something called dot graphs. But I'll show you a way by which you don't have to do that. And instead, it'll be very helpful because in each step, you will be able to see how many parameters you've
cool. That's cool.
So let's get back to this. So sequential model is just a fancy word to say that steps happen one after the other. So if you've heard of feed-forward neural network, that's the same thing as sequential. Sequential has nothing to do with time series. Oops. Okay, so the first layer I need is the input layer. Layers. This is a standard layer, so I don't need to look into this thing, the API. So here, all I need to specify is the input shape. And the input shape here is xtrain.shape. For each image, the height is 28 pixels and the width is 28 pixels. So I know that it's 28 by 28, but I'm also going to add a channel dimension. This is true for all deep learning libraries. If you're passing in images, that means you're about to use layers that are image specific. You must pass in the channel dimension. Channel is the color channels. In a grayscale image, you just have black and white. So you just have one channel. In RGB, there are 3 channels. If you're using ultraviolet and infrared, then you'll have 5 channels and so on and so forth. So this is the number of channels that there are. And yeah, the first step I'm going to do now is pre-processing. So layers. I'm going to do rescaling. The reason is because this was an integer from 0 to 255, and I need to specify a scale. Again, this is another practice that I'm trying to force it onto people. If you pass this parameter raw, the first parameter is input shape. So you will immediately know that this parameter is assigned to input shape. But I prefer actually spelling it out so that people are very clear exactly what parameter I'm passing. So I'm spelling it out, even though scale was the first parameter defined into rescaling. In scale, I'm passing a 1 divided by 255. So all that's going to happen is that every single pixel is going to get multiplied by 1 divided by 255. So if it's 255, the value will become 1. If it's 0, it'll stay 0, and everything in between. So that's rescaling. Now we need to specify the model. So
okay,
let's
quick question. I see you're using internal products and internal devices with the dot notation, which reminds me of that, by the way. I was just noticing you're using the dot notation for internal product. So undivided.
Oh,
right?
this in Python, this indicates that this integer has to be transferred and converted into a float. And this is also true for JavaScript, as I know.
Oh, is it? I didn't know that.
Yeah. Yeah, the reason is because this will, if I didn't do this, it will get rounded off to a nearest integer.
Yeah.
That's what I'm preventing. You don't need to do this here, but I'm just being paranoid. Anyway, let's try linetify. This was a very famous architecture that Jan LeCun proposed. Let's try to reproduce this paper. Yeah. So this is the LaNet architecture. This is AlexNet. Let's try LaNet. LaNet works really well for things like MNIST or digit recognition, handwriting recognition in general. So you have 28 height and 28. He did this on MNIST, so it's quite convenient for us. So I'll just move it next to this. Let's look at these layers. So I've got 28 by 28 by 1, which is here. Scaling had to be done, but this guy did it as a pre-processing step. The first step is a convolution layer with 5 by 5 kernel and 2 padding. So padding means that I'm going to pad my image with zeros. On 2 means that I'm going to add 2 rows of zeros on the top, 2 rows of 0 on the bottom, 2 rows of 0 on the left, 2 rows of 0 on the right. This is just done to make sure that the convolution operator does not miss any signal. So it just allows me some free space to move my window of convolution layers. That's the reason people do this. So I'm going to do that padding first. Dot layers, and that's called zero padding. Yeah, zero padding for the 2-dimensional image. I don't remember. Oh yes, padding. If I pass an integer 2, it's going to symmetrically do this on the high, 2 on the top, 2 on the bottom, 2 on the left, 2 on the right. So what is going to happen? My 28 by 28 by 1 image is going to get transformed into 32 by 32 by 1 image. So once I've done with the zero padding, I need to do convolution. Keras.layers.con. Cont2D, yeah. Cont2D has, so I need to specify the number of filters. Filters is the number of features in your image. In this case, it was 6. So the output of this layer is 28 by 28 by 6. So I know that there are going to be 6 features. So I'm going to set the filters to 6. The next thing I need is the kernel shape. That's 5 by 5. So kernel size. If I just specify phi, it symmetrically does for both height and width. So I'm going to just set it to a constant. Another thing I need to do is activation value. The activation value here is sigmoid. So just, this is completely outdated as you can imagine, but it still works. So let's just use sigmoid to pay our respects. Next I need to do is pooling. Again, this is also an outdated version of pooling called average pooling. And it has a stride of 2. So let's try that. Layers.average. Yeah, average pooling 2D. Yeah, auto-completion is really helpful here. So, oh, sorry, no filters. So there is pool size. I'm going to set it to 2. This will symmetrically do it for both height and width. Then I have a stride of 2. Strides is also 2. Is there anything else? That's it. Okay, so the next 2 layers is going to be similar. There's going to be another convolution and another pooling. So I'm just going to copy and paste it. This is highly not recommended. I'm going to paste it and I'm going to change the properties. The number of filters here is gone to 16. 16. The kernel size stays as 5, and the activation is again sigmoid. So activation is sigmoid again. Then again, I do average pooling. That's 2 by 2 kernel, 2 stride. That's it, which is identical to the previous one. And I'll show you a trick on how to confirm these things. All I have to do now is flatten. Flatten is another popular layer. Then I need to have a sequence of 3 dense layers. And this is sigmoid, this was sigmoid. In his original paper, this was a radial basis function, but I'm going to do softmax because it's faster. Start dense, sorry. The number of kernels here, this is 120, and the active units is 120, and the activation here is sigmoid. Again, the units is, how much was it, 84? 84. 84. Activation is sigmoid. Oops, yeah, that's it. Then units is equal to 10. 10 is the number of classes. You have 0 to 9. And the activation is softmax. Okay, this is my entire model. Then I'm going to do model.compile. I want to specify the loss function. I'm going to use losses sparse cat. This is I'm using cross entropy. Then I need to specify the optimizer. So I'm going to use Adam, all defaults, and I'm going to observe the accuracy. Categorical accuracy, this is the one. That should be enough. Now, Jonas, this is how I visualize this. So I do model.summary. Yeah. Yeah. So take a look at this. This is how people, even Andrew Ng, Jan LeCun, when they program, they always verify this. So they first draw this diagram and they write the expected dimension of the tensor. And if you've coded it correctly, it should match with this. So let's take a look at that. So you've got an input 2828.1, which is correct. And after padding and after the first convolution, it comes to 2828.6. So after padding and after convolution is 2828.6. And then after the pooling, it's 1414.6. It's 1414.6. Then after the second convolution is 1010.16. It's 1010.16. And then after the averaging, you've got 5516. 5516, and then this is expected. So now you've got 61,000 trainable parameters. This would take a long time to train on a CPU, so I'm going to change my runtime environment.
Jay, if this was not a sequential model,
yeah,
how would you address the, I guess, graphical representation?
Oh, functional API, beautiful it is. That's the one that I show you typically, Jonas, when we meet. Yeah, functional API is like you would make functional calls to it. So you would create each layer as if it was a function, and then you'd pass the output of that layer into another function, so on and so
forth. That is beautiful.
Yeah, it's very elegant. Anyway, so I'm switching my runtime to a GPU, and I have to rerun everything. Hope we have the time. I guess we don't. Yeah. It should take a few. So I'm going to do the model fit now. Here I'm going to show you a trick. So I'm going to do model.fit, and I'm saving the output into history, and I'll show you why I did that. This way you can avoid TensorBoard. I'm going to pass train. So Praful, I'm passing in an NumPy array here, and it's going to be fine. Then I'm going to use the epochs to, let's set it to about 20. And I'm going to set the, what else do I need here? A batch size. Size is equal to 32. Yeah. This should be enough. If you had a TP, you would typically set the batch size to something much larger, like 1024. Otherwise, you won't have any benefit of TPs. This is going really fast, by the way. If you tried doing this in your computer, it would take about 30 to 40 minutes to train. I'm going to anticipate the results. So I take the data frame, and I'm going to plot it. This is the trick that I'm saying, and R has a very similar trick to this. What I'm doing is that whatever history object is going to be returned by this fit process, I'm going to take the key history, and I'm going to convert that into a data frame, and I'm going to immediately plot it. Dot show. And this way you don't need TensorBoard to run. Again, anticipating the next step, I would want to show you the performance of this model. So I'm going to do model.evaluate, and I'm going to run it on the test set, and I'll get the performance. Then the next step is going to be to convert the model directly. So I'm going to I'll have to save the model. So I need to mount this. I think this won't be a problem because this is a CPU operation. So this is an important step. I'm just going to click this button, mount drive. I'm not calling the API for drive at all. I just click this button and I click to Google Drive. That's it, the auth is done. Let this go on.
So Jay, at the end of this, just to remind the plan, you export this into a package of some sort, and Praful can consume it, right?
Exactly. So I'm going to save this in a saved model format, which is native TensorFlow. It can be read from any language. Second, I'm going to save it as a JSON so that Praful can immediately consume it in TensorFlow.js. The third one, I'm going to create Onyx so that this is a highly interoperable solution where you can port it to other neural network libraries. So yeah, the mounting is done. This is my drive. This is actually my personal drive account. This is my personal account. You can see my product.
You probably touched on this, but just in case you didn't, are you using a TPU on this one?
No, I'm a GPU. If you use a TPU, you'll have to do a few things differently because it behaves similar to a CPU in terms of how you. So the thing is, do you want to delegate everything to the model? That's going to be ideal if you're going to use a GPU. There are certain operations you should not delegate to the model if you don't want to use a GPU, because otherwise your GPU will be idle for a long time. So what I'm essentially trying to say is that your programming style completely changes when you're programming for a CPU, or sorry, GPU or a TPU. So yeah, this was entirely done for GPU, which is the most common case. So I've mounted my drive, and just for you guys to see it, drive.google.com. You guys can graphically see this. This is my drive. I've got these folders in my parent directory, and I've got projects. Yeah, so here, this is my projects directory. I'm going to just create completely like it's a GUI. I'm going to add a new folder. Let's call this Lenet5 project. And this is what I'm going to give governed access to people that I want to. So this thing is done. I just want to show you guys something. So you see, you quickly built a visualization, and there's no computational cost of adding a callback function like a tensor board. Here you see my my loss function going rapidly down, and that has reached some kind of a convergence. And you can see my accuracy, my predictive performance. It has gone up, and it has also tapered off. And this is the number of epochs. Yeah, so let's see the evaluation of the performance. So here I can see this is my loss, and this is my predictive performance. That's 98.7 accuracy, which is pretty good. So, and this is actually as close to state of the art as you can get with this data set. What I'm going to do now is I'm going to save the model in this, and I'm going to copy the path. Let's call it dir. I think we'll only be able to do the Python part today. So dir, I'm going to save the model using a simple command .save, and I'm going to pass the path start path.join, and this is my directory path. And now I need to come up with a name for the model, so I'm just going to call it Lenet5. That's it. That should be enough. Yeah. So I've saved it here. This takes some time to refresh. So here, this is my saved model format. So I can come here and I can also refresh it. So this is my Lenet5 project. By the way, you can already see this is similar to Box now. I can give access to anyone here this way. So I'll immediately start adding people. Can people just add your accounts? Definitely Jonas and Praful have to be there. Even Daniel, if he's interested, we can explore R on another day. So yeah, please add it onto the chat room. In the meantime, I'm going to save this in another format.
I thought you might prefer to make it available as view only, but public, or you see.
I'm going to give write access to Praful.
Oh, right as well. Of course, Praful needs it.
I don't think so. Yeah.
Do
you need write access?
I don't think so. I'll only be using the URL to the model, right? So I don't think I'll be.
Yeah.
In fact, is it possible to just open the link to everyone?
Yeah, you can.
Yeah, view only. View only. I see you had on the lower end of the box in the share. Yeah, get link down.
Is anyone with the link?
This is a view.
Yep.
Okay, so I'm adding this here so you guys can start playing with it immediately.
I'm hoping we don't get any course errors.
Course? Why would there be a course error here?
If you expect it to, I'm not sure, but because you're calling it with fetch, we'll go through course. I mean, because I'll be calling it with fetch, I'll go through course. Hopefully, that's not the case, but let's see. Google Drive is picky about that. I had to write my own proxy when I was doing the NNIST server. Let's see.
Praful, this is what you were talking about. Yeah, for everyone else, if I saved it as a H5, I would create a HDF5 format of the model. I think this is relevant to R programmers. That's why I'm keeping this format here. I'm also actually, I'll come to this later. I'm going to, so Praful, this is how I convert it into TensorFlow.js. So this is again a command line command. This I got because I imported TensorFlow.js library from Python. I'm going to keep the input format as Keras saved model, and I need to specify the current the directory where this is located. So it's going to be this /lennet5, right? Yeah, it's lennet5. That's this folder. And next, I need to specify the target. So I'm going to paste this again. Then I'm going to call it lennet5 JS. So JS is what Praful is going to consume. Let's see if this works. If there is an error here, then Praful will not be able to build this model, and I'll have to change something. Yeah, it worked. So Praful should not have any trouble running this. And I'll quickly go through the JSON model. I'm just going to print out one more model type, and that's Onyx. So let's take a quick look at Onyx. TF to Onyx. So I go into here. So all I need is, since I've already imported this, all I need is this command here. Again, this runs on the command line. So I'm going to do exclamation mark. This is fine. This is the path where my TensorFlow saved model is. So that's this one right here. This one. And I need an output file. So I'm going to again use this. But I'm going to call it lennet. I'm going to call it lennet5.onyx. So let's see if Onyx compiles. So we need to, oh, it's fine. Okay, let's take a quick look at what we've generated. So all of you guys have access to all of this model. Feel free to play with it. This is, if Praful chooses to use the Onyx web runtime, then he will use this. Since I did not have any compilation error, it's going to work perfectly. Let's take a quick look at the JavaScript one. You can actually, and Jonas, this is another great thing about Google Drive, which you already know, but you have these additional apps, right? And I can view it using JSON viewer rather than using it. If I viewed this as a document, I would have a difficult time. So you see, I can beautifully render JSON files this way. So because you have the entire Google Workspace apps available here from the Chromium OS. So yeah, let's just collapse these. So this is what the model looks like. I compiled it from Keras version 2.7, so Praful knows that. He also knows that this is designed for the converter for TensorFlow.js version 3.12. And this is, let's look at the weight model topology. Here in the model config, again, you know that this is a sequential model, and you know step by step, this is the input layer, the rescaling layer, the padding layer, and so on and so forth. So you've got the entire steps right here. He also knows how I trained it. So he knows what I optimized on. And he knows what metrics I was observing. And from the weights manifest file, he also knows the dimensionality of tensors that are going to come out of it. So that's what's contained in the JSON file. Bin has all of the weights. So the combination of these two should run on TensorFlow.js. For folks who are R users or some other language, even Go or Rust, I think that H5 is the best one. But if you guys can figure out how to run this Linet 5, then I think this would be ideal. Jonas, do you want me to save the data set into these folders?
Or the link to it. I guess you provide the link to it, right?
My concern with providing the link is that it was designed for NumPy, and if you guys use some other library, so I think let's test out Jonas's idea. So he was suggesting why not just use these folders to save data, which actually makes perfect sense. There won't be any compilation error. I already tested this. So for Praful, I'm going to store it here. For for Praful, I'm going to store it here. For everyone else, I'm going to store it here. So I need there are three primary targets that we can try. One is ZAR, which is not going to work for R. It will work for JavaScript and Python. So ZAR is off the table for that reason. The second thing I thought was TensorFlow records format, which is a binary file format recommended by TensorFlow. Ironically, it is supported by only R and Python, and it's actually not supported by TF.js. So that's why TF records is off the table. The only format that I could think of was HDF5. So if someone wants to rescue me, you can. But I'm going to save it in HDF5.
Praful, any comments? That sounds good to you?
Yeah, no worries.
Because I remember you have the MNIST state in some other format for TensorFlow.
Yeah, I have it in PNG. Yeah.
Okay. So we're going to hit in 3 minutes the mutation signature people.
I'll just quickly add the data here, and I'm done. Do you guys want to see me do that, or?
Yep. Let's observe it. Praful, so today is the last official Cloud4 Bio of the year. But what I propose is that I think, Jeya, both you and Praful, you guys are available, right? Wednesday?
Yeah, I am.
So we'll have a clandestine Cloud4 Bio to see the TensorFlow side of the story. This is being recorded, and all the links that you see on the chat box, I also put them on the wiki. So we would have a week to study what you did at length, Jeya.
Okay, sounds good. I'll just quickly show you guys how to move data into it, and this was Jonas's idea. What I'm doing now is I am creating a directory called data. That's it. And I also need to do that for, what was the other one? Oops, sorry, data is not defined. The other one was JS, right? So I'm going to put that into JS as well. I know this is not the ideal way to do it, but I'm messing that up here just in the interest of time. And sorry. Let's see. So I've created a directory here called data. No. Yeah, I can see it here, but I think it'll take some time, but I can see it in both these places. So I'm going to continue on. Wait, did I? No, okay. What I want to do is I'm going to save this as a h5 file. So with h5py.file, and I'm going to call this, again, this is a bit shabby. I'm going to call, let's call this train for train Linet 5. And inside there is going to be a data folder. And I'm going to call this as, okay, let's just use this file. So this is my regular data. And I'm going to also have one for JS. Okay, this looks good. I'm going to use the data directory, and I'm going to do a write operation as h file, and h file, I'm going to do a write, I think. What's the option here? Create dataset. Yeah, I'm going to do a create dataset, and I'm going to call this dataset as train. And I'm going to set the data value to x train. Okay, let's call it train x.
Hey, Jeya, we ran out of time. I see the new crew walking in.
Okay, so yeah, I'll just, using these commands, I'm just going to save the data in HDF5 format, and then we can take it up from
And
the
I
next
think
step.
this is actually perfect because this will give us a week to catch up, and we'll be ready for you, Praful, next Wednesday.
Yeah, I mean, there's a bummer here. I tried using the model URL Jeya shared, and it does have the cost problem. But let me see if I can figure something out.
We can maybe set a proxy or something.
I'll have to download the model for that. But
Well,
let's see.
that would be an acceptable shortcut, Praful. No problems. Everybody knows how to go around cores these days.
Okay, download the model in a place that I control. That's not ideal, but that's fine. Let's
What about
move on.
GitHub? We could move it to GitHub, GH pages.
Yeah, that might work, but then the code becomes separated from the model.
Yes.
Which is
Yep.
okay.
That's very elegant. All right, so we move to the second part.